The Last Light, a journey forward in time to the very end of the universe and the final glimmer of light within it. Everything you know is temporary. The sun, the stars, the galaxies, even the atoms in your body will all, one day, be gone. Tonight, we travel forward through time, leaping by powers of 10, watching the cosmos slowly age and dim, all the way to its final, silent state. It's a long, strange road. So let's begin at the beginning, right now. Here is the universe today, not quite 14 billion years old, and gloriously alive with light. Hundreds of billions of galaxies, each with hundreds of billions of stars, all shining at once. New stars are still igniting in great clouds of gas. This is the bright morning of the cosmos, the era we were born into. But mornings don't last, and from here, the light only ever fades. Our first stop is just 1 billion years from now. The sun is a middle-aged star, and like all stars, it slowly grows brighter as it ages. In about 1 billion years, it will shine some 10% stronger, and that's all it takes. Earth's oceans begin to evaporate. The air thickens with steam, then boils away into space. Long before the sun itself dies, our planet is already a scorched, lifeless rock. Life on Earth has an expiry date, and it comes early. 5 billion years from now, the sun finally exhausts the hydrogen fuel in its core. In its dying struggle, it swells into a red giant, hundreds of times its present size. One by one, it engulfs its closest worlds, Mercury, then Venus, and quite possibly the Earth itself. The inner solar system is consumed by the very star that once gave it life. It's a violent, strangely beautiful end, but it is only the opening act of the long dark to come. When the red giant has burned through the last of its fuel, it gently casts off its outer layers, painting a glowing shell of gas across the dark. What's left behind is the sun's bare, exposed core, a white dwarf, almost unimaginably dense, no larger than the Earth, yet still holding half the mass of the Sunday. It will shine faintly from leftover heat alone, cooling, dimming, and fading over trillions upon trillions of years. The planets that survived the red giant keep circling, but the warmth is gone for good. Around the cooling ember of the dead sun, they drift through perpetual night, frozen solid, silent, and black. The solar system that once held a living, breathing world becomes a quiet graveyard, gliding through an emptying galaxy. And remember, our sun story is just one of billions, all playing out across the cosmos at the same time. Now leap to 100 billion years from now. Dark energy, the mysterious force pushing the universe apart, keeps accelerating that expansion. Distant galaxies are carried away faster and faster until they cross a cosmic horizon and their light can never reach us again. One by one, the galaxies of the night sky simply wink out. A future astronomer would look up and see almost nothing, no hint of the vast universe that once surrounded them. Closer to home, the Milky Way and our giant neighbour Andromeda have been falling toward each other for billions of years. By now, they've collided and merged into a single, enormous, elliptical galaxy, sometimes nicknamed Milkomeda. But there is no one left to admire it. Beyond its edge, the sky is utterly black. This merged galaxy floats completely alone, a single island of light, in an ocean of nothing. 1 trillion years from now, the galaxy is running low on the one thing it needs to keep shining: cold clouds of gas. Star formation depends on that gas, and it's nearly used up. Fewer and fewer new stars are born to replace the ones that die. The brilliant, crowded galaxy of today slowly thins out, growing dimmer with every passing eon, as its brightest stars burn out and are never, ever replaced. The biggest, brightest stars always die first. They burn furiously and fast. The small, cool, red dwarf stars are far more patient. They sip their fuel so slowly that they can shine for trillions of years, and so they are the very last to go. Around 100 trillion years from now, a number so vast that all of cosmic history up to today is barely a rounding error within it. The final red dwarf flickers, dims, and goes dark. The last star in the universe has died. And with that, an entire age of the universe comes to a close. For its first 100 trillion years, the cosmos was defined by starlight, what scientists call the Stelliferous Era. Now that era is over. No new star will ever be born again. There will be no more dawns, no more sunsets, no light from any sun anywhere. The universe goes dark, and it will stay that way essentially forever. But darkness is not the same as nothing. We enter the Degenerate Era. The corpses of the old stars still remain, scattered through the black, white dwarfs, slowly cooling, dense neutron stars spinning down, the cold husks of dead planets, and the black holes left behind by the largest stars. They drift through a void lit only by their own faint, fading glow, the embers of a fire that has already gone out. For unimaginable stretches of time, almost nothing happens at all. But once in a great while, purely by chance, two of these dead remnants drift close enough to collide. For a brief moment, they blaze back to life, a sudden flare of light and heat in the endless dark, a star reignited for just an instant, and then it fades again. In this era, these rare collisions become almost the only events left to mark the slow passing of the ages. Slowly, gravity reshapes everything, one final time. Within each dead galaxy, chance encounters fling some stars out into the empty space between galaxies, while others spiral inward and are devoured by the supermassive black hole at the centre. Over spans of time beyond comprehension, the galaxies themselves come undone, their stars scattered or swallowed until the great structures of the cosmos have completely dissolved away. And then, perhaps, matter itself begins to die. Many theories predict that the proton, a basic building block of every atom, is not perfectly stable. Given enough time, more than 10 to the 34th years, even protons may slowly decay into smaller particles and radiation. If so, the white dwarfs and neutron stars, the last solid objects left, slowly evaporate from within into a faint haze of light. We aren't certain, but if it happens, it's the end of ordinary matter. By around 10 to the 40th year, the universe has been swept almost completely clean. The stars are long dead, their remnants have evaporated, the frozen planets are gone. There is, quite literally, nothing solid left anywhere in existence, with a single stubborn exception. One kind of object endures, having outlasted absolutely everything else, now ruling over the empty cosmos. The black hole era. For a span of time so vast it makes everything before it look instantaneous, the universe belongs entirely to black holes. They are the last great structures, standing silent, dark, immensely powerful, drifting through an infinite emptiness. If anything could watch, it would see a cosmos with no stars, no galaxies, and no light at all, only these invisible giants quietly marking where matter used to be. But not even black holes last forever. Thanks to a subtle idea from Stephen Hawking, black holes are not perfectly black. At their edge, they slowly leak a faint trickle of radiation into space and lose a tiny bit of mass. Bit by bit, over spans of time that dwarf everything we've seen so far, they shrink. The most permanent objects in the universe are very, very slowly evaporating away into nothing. How slowly? A black hole the mass of our sun would take about 10 to the 67th years to evaporate completely. That's a 1, followed by 67 zeros. To put it mildly, that is unthinkably longer than the entire age of the universe, so far longer than your mind can really hold on to. And yet, on the timescales we're now exploring, the smaller black holes like this are the quick ones, the first to vanish. The largest black holes, the supermassive monsters that once anchored entire galaxies, hold on the very longest. They take around 10 to the 100th years to fully evaporate. That number even has a name, a googol, a 1, followed by 100 zeros. These are the last structures in the universe, slowly bleeding their energy away, the final embers of a cosmos gone completely dark. And then, at last, after a span of time that defies all meaning, the very last and largest black hole reaches the end of its long, slow evaporation. In its final instant, it doesn't simply fade, it releases the last of its energy in a sudden, faint burst of radiation, a final flicker of light in the dark. It may well be the last meaningful event the universe will ever experience after this. Nothing of any consequence will ever happen again. The cosmos has spent itself completely. We have entered the Dark Era, and it is, for all intents and purposes, forever. All that remains of the once glorious universe is an unimaginably thin, cold fog. A scattering of stray photons, lonely electrons, and other lightweight particles, drifting ever further apart in a space that simply keeps expanding without end. No stars, no planets, no black holes. Just a faint, freezing mist stretched thinner and thinner across an infinite void. This is what physicists call the heat death of the universe, not a fiery end, but a frozen one. As everything spreads out and cools toward absolute zero, the temperature differences that let energy flow, that let anything happen at all, gradually disappear. Entropy reaches its maximum. The universe settles into a state of perfect, featureless equilibrium, where no work can be done, no structure can form, and nothing can ever truly change again. And there it remains. No stars, no structure, no warmth, no events. Just darkness and silence, stretching onward, with no end, anywhere in sight. Time itself continues, but with absolutely nothing left to happen, and no one left to witness it. Even time begins to lose its meaning. This is the universe's final, eternal state. Empty, cold, and perfectly still. So that is the whole story, told in 5 great chapters. The Stelliferous Era, the brief, brilliant age of stars, the one we live in right now. The Degenerate Era, lit only by the cooling embers of dead stars. The Black Hole Era, when only black holes remain, slowly evaporating. And the Dark Era, cold, empty, and eternal. 4 of those 5 ages are dark, lasting not billions of years, but numbers with dozens, even hundreds of zeros. Against all of that, the age of starlight is almost nothing. Stretch that whole timeline out in front of you, and something remarkable becomes clear. The age of stars, the only time the universe is full of light, the only time life as we know it could possibly exist, is a single dazzling sliver, right at the very beginning. A tiny bright flash before an almost infinite darkness. And out of every possible moment in the unimaginable lifespan of the cosmos, we happen to be born into that one shining sliver. Almost all of time, very nearly all of it, will be cold and dark and empty. The stars are a fleeting miracle, and we are alive while they still burn. That isn't a reason for despair. It's the rarest kind of luck imaginable. We are here, conscious and awake, in the brightest, most extraordinary chapter the universe will ever have. So while the lights are still on, look up and don't waste it.